Hello everyone, this is the fourth video of electrochemistry, and in this video we are going to discuss Kohlrausch law. So what does Kohlrausch law say? It says that the limiting molar conductivity of an electrolyte is equal to the sum of limiting molar conductivities of its constituent ions. For example, NaCl is an electrolyte, so it will form Na plus and Cl minus ion. So what will be the limiting molar conductivity of NaCl? It will be equal to limiting molar conductivity of Na plus ion plus limiting molar conductivity of Cl minus. So it is said by Kohlrausch law. Similarly, there is one more compound like MgCl2. So MgCl2 is going to form Mg2 plus Cl minus ion. So what will be the limiting molar conductivity of MgCl2? It will be equal to limiting molar conductivity of magnesium ion plus twice the limiting molar conductivity of chloride ion, because there are two chloride ions given by one MgCl2. So this is how we can use Kohlrausch law in various numericals. So let's see some numericals. So this is the question: molar conductivity at infinite dilution for NH4Cl, NaOH and NaCl solution at 298 Kelvin are 129.8, 218.4 and 108.9 Simon centimeter square per mole respectively. Molar conductivity of 10 raised power minus 2 molar solution of NH4OH is 9.33 Simon centimeter square per mole. Calculate the degree of dissociation of NH4OH. So in this question you have to calculate the degree of dissociation of NH4OH. Now the degree of dissociation of any substance means alpha is equal to lambda m by lambda naught m, means degree of dissociation is equal to molar conductivity of that substance divided by limiting molar conductivity. So you have to remember this formula, because you know that limiting molar conductivity, that means molar conductivity at infinite dilution. So molar conductivity at infinite dilution is called limiting molar conductivity, as we have discussed in the previous lecture. So alpha equal to lambda m by lambda naught m, or degree of dissociation is equal to molar conductivity of a substance divided by limiting molar conductivity of the substance, because at infinite dilution the substance is almost completely dissociated. It means its degree of dissociation will be 1 at infinite dilution. So remember, alpha is equal to lambda m by lambda naught m. So we have to find lambda naught m for NH4OH, because lambda m is given. So lambda m is equal to what? Lambda m is equal to 9.33 Simon centimeter square per mole. Now what do we have to find? We have to find lambda naught m for NH4OH. So how will we find it? Lambda naught for NH4Cl and NaOH and NaCl is given. So we can write lambda naught NH4Cl, that is ammonium chloride, is given, that is equal to 129.8 Simon centimeter square per mole. Similarly, lambda naught for NaOH is also given, that is equal to 218.4, and lambda naught for NaCl is also given, that is equal to 108.9 Simon centimeter square per mole. So from Kohlrausch law you can write down lambda naught NH4 plus lambda naught of Cl minus, that is equal to 129.8. You can write down it, equation 1. Similarly, lambda naught Na plus lambda naught OH minus, that is equal to 218.4. This is your equation 2. And lambda naught Na plus lambda naught Cl minus, that is equal to 108.9. So we need lambda naught for NH4OH. So you can see NH4 ion is in this equation and OH minus ion is in this equation. We can write equation 1 plus equation 2, but we will also get Na plus and Cl minus, and it is equation 3. So we have to subtract that minus equation 3. So by adding and subtracting, we will get this plus this minus this. So Na plus ions will be cancelled, Cl minus ion will be cancelled. So what will we get? We will get lambda naught NH4 plus lambda naught OH minus is equal to 129.8 plus 218.4 minus 108.9. So this is lambda naught NH4 plus OH minus, that will be NH4 OH. So that will be equal to 129.8 plus 218.4 minus 108.9. So that will be equal to 239.3 Simon centimeter square per mole. And now we can calculate the value of alpha. Alpha is equal to lambda m. The value of lambda m is 9.33 divided by the value of lambda naught m. Lambda naught m for NH4 OH, that is 239.3. So you can calculate its value. So that is approximately equal to 0.039. So this is the degree of dissociation for NH4 OH. The next topic is electrolysis. Electrolysis is the process in which electrical energy is converted to chemical energy. It means in the process of electrolysis, a chemical reaction will take place with the help of electricity. तो आपको ये ध्यान रखना है कि हम किसी भी सॉल्यूशन से जब इलेक्ट्रिसिटी पास करते हैं तो उसकी वजह से कोई भी केमिकल रिएक्शन होती है और उसी प्रोसेस को हम कहते हैं इलेक्ट्रोलिसिस. तो इलेक्ट्रोलिसिस के बहुत सारे यूजेस हैं. फॉर एग्जांपल इन मेटलर्जी, देन इन प्योरिफिकेशन ऑफ मेटल्स and electroplating, etc. Now, how the electrolysis will take place? It is given by two laws, Faraday's laws of electrolysis. Faraday's first law says that the amount of electrolytic deposition on any electrode is directly proportional to the amount of electricity passed through it. मतलब किसी भी इलेक्ट्रोड पे जितना भी सब्सटेंस डिपोजिट होता है, क्योंकि किसी भी केमिकल रिएक्शन में क्या होता है, सब्सटेंस डिपॉजिट होता है कैथोड पे, तो कितना कैथोड पे डिपॉजिट होता है और अगर लिबरेट हो रहा है तो एनोड से कितना लिबरेट होता है, दैट इज डायरेक्टली प्रोपोर्शनल टू द क्वांटिटी ऑफ इलेक्ट्रिसिटी पास थ्रू इट. तो मान लेते हैं इलेक्ट्रिसिटी मीन्स कि कितना चार्ज आपने पास किया, दैट इज क्यू, एंड डब्ल्यू इज द मास ऑफ दैट सब्सटेंस. सो यू कैन से डब्ल्यू इज डायरेक्टली प्रोपोर्शनल टू क्यू. क्यू मीन्स आई इंटू टी. आई इज करंट एंड टी इज टाइम. तो आपको पता है I is equal to Q by T, तो Q will be IT, or you can say Q equal to Z into I into T. So Z is a proportionality constant here. Z is a proportionality constant called electrochemical equivalent. Now, Faraday's second law, it says if the same amount of electricity is passed through the solutions of two different electrolytes, then the amount of substance deposited on the electrode is directly proportional to the equivalent masses of those substances. तो मान लेते हैं कि हमारे पास यहाँ पे जिंक और कॉपर सल्फेट के दो अलग अलग इलेक्ट्रोलिटिक सॉल्यूशंस हैं. तो एक सॉल्यूशन हमारे पास ZnSO4 का एंड देन सेकंड वन इज ऑफ कॉपर सल्फेट. तो फैराडेज सेकंड लॉ कहता है कि किसी भी सॉल्यूशन में अगर जिंक सल्फेट का है या कॉपर सल्फेट का है, अगर इसमें हम सेम अमाउंट ऑफ इलेक्ट्रिसिटी पास करते हैं दोनों सॉल्यूशन में, तो ये कहता है कि मास ऑफ जिंक डिपॉजिटेड डिवाइडेड बाय मास ऑफ कॉपर डिपॉजिटेड इज इक्वल टू, क्या हो जाएगा, दैट इज इक्वल टू इक्विवेलेंट मास ऑफ जिंक डिवाइडेड बाय इक्विवेलेंट मास ऑफ कॉपर. तो ये आपको दो लॉज ध्यान में रखने हैं जो कि आपको फॉलो करने हैं किसी भी न्यूमेरिकल प्रॉब्लम को सॉल्व करने के लिए. सो दिस इज द फैराडेज फर्स्ट लॉ विच सेज दैट the mass of substance deposited on an electrode is directly proportional to the amount of electricity passed through the electrolytic solution। और दूसरा हमारे पास सेकंड लॉ जो कि कहता है कि अगर आप सेम अमाउंट ऑफ इलेक्ट्रिसिटी पास करते हो दो अलग अलग सॉल्यूशंस से तो जो मास डिपॉजिट होगा इलेक्ट्रोड पे वो डायरेक्टली प्रोपोर्शनल होगा उन सब्सटेंसेस के इक्विवेलेंट मासेस के। तो आपको ये ध्यान रखना है। तो आज हमने जितने भी क्वेश्चंस डिस्कस किए, अगर आपको उनमें से किसी में भी कोई डाउट है तो आप मुझे क्वेश्चंस कर सकते हैं कमेंट बॉक्स में। थैंक यू वेरी मच।